Now again, validity is referring if the instrument measures what it intends to measure. Now, how do we demonstrate evidence if the research instrument has a construct validity? Like remember, for example, if the person said he or she has a high anxiety towards mathematics, is it really seen in real life? Or if the student says that it's a self-perception on mathematics skills. So for example, if the student perceives that he or she is really good in math, will the examination score also validate the answer? Now, let us check what are the evidences to check construct validity. Now, there are three evidences. First is homogeneity. If we say homogeneity, let me use my pen first. Homo, it means just one. Homogeneity tells us that the instrument only measures one construct. For example, wait, let me check. I am freezing here. Now, for example, we will have a question on attitude towards mathematics. I'm really sorry, my questions, my examples will all be on math because that's my research field. For example, attitude towards mathematics and also on their academic performance. Let's talk first on attitude towards math. Example question number 1. I like to study mathematics. Number 2, I believe I can do good in mathematics. Number 3, I feel belongingness in a mathematics class. Questions 1 and 2 can talk about attitude. But question number 3 is on the sense of belongingness in a math class, which is not a question or not an item for attitude towards math. So we see that when we have the instrument, there is homogeneity. The second one is convergence. In convergence, it occurs when the instrument measures concepts similar to that of other instruments. We don't find very similar instruments, or else you'll be charged of plagiarism. That's not possible. But we check on the similarity. For example, if Mr. A wrote, I like to study mathematics. Can you rephrase it to, I like my study habits in mathematics are good? So we check, is my item similar to somebody's item? Not a copy paste, okay? Not a copy paste, but a similar one. Then the last one, third one, theory evidence. For example, if this will be my statement, what does the theory say? Example, let me deal on Joshua's study. Joshua's study is on students' perceptions in the online learning environment and academic performance. For example, item number 1 in the question is, I feel like dropping in my online class. What does the theory say? Why did you write it? Oh, the theory say that in an online class, retention level is only 25%. So if there are 100 students, basically the online learning theory says that only 25 will survive the class. So my item will be okay. Or another, let me go back to Kaiser's question. Study, reading comprehension. My question number 1 is, I can understand all the given words. What does the theory on reading comprehension say? Child's reading comprehension say that if you have a good reading comprehension, then you can find the synonym of these words. So I need to rephrase my statement because understanding or defining is not enough. I need to find synonyms. So that is theory evidence. Now let's go to the next one. That is for construct validity. How about for criterion validity? Now, what is criterion validity again? Criterion validity happens when your instrument measures the same with other correlated instruments. Example, the first one is convergent validity. Now, suicide or geriatric suicide, this is a suicide among elderly, like 65 years old and above. Geriatric suicide is positively correlated with depression, loneliness, and hopelessness. For example, if I'll make a questionnaire on suicide, or if I'll note the variables, I'll do observations on people who are prone to geriatric suicide, is it the same with the symptoms they manifest for depression? Or if I'll have a questionnaire, is my questionnaire for depression almost similar with my questionnaire for loneliness? That is a convergent validity. In the next one, in divergent validity, it means that, diba, converge. If both variables are having the same symptoms, they must have the same, almost the same questions. Diverge. If they are different, then questions must also be different. Example, motivation and self-efficacy. Stop. Or we say, wait, give me a moment first. Two different variables. Example, a while ago, mathematics attitude and student engagement. This variable and this variable are different. Therefore, the questions or the items must be different as well. It should be a divergent validity. And the last one is predictive validity. It tells us if the instrument should have it should be highly correlated with future criteria. For example, study says that if you have a high self-efficacy, it's almost synonymous to self-confidence, then most likely you will complete the task. So if I answer a questionnaire on self-efficacy and I rated it very high, what is my degree of task completion? Another, remember a while ago, I'll type in the chat box. I can write. For example, here's another study. Self-perception on math skills. It's how you believe yourself on how good are you in math. Now, self-perception and math skills. For example, if I mark myself, if I perceive myself to have a high level of math skills, will it be seen also in my examination scores in math? Or if my teacher will test my math skills, will the questionnaire correlate with the data? That is a predictive validity. So teachers will say, the student has a high self-perception on his or her math skills. So possibly he or she will get a good exam score. That's a predictive validity. Now, remember the three. Okay, again, let's have a review. What is validity? Validity tells us that the instrument measures what it intends to measure. There are three ways. Content validity, it means all the items measure the same content. Construct validity, it means all the items will measure the same with a real-life construct. And the last is criterion validity. Your instrument measures almost the same with the other correlated values. Next is reliability. Now, what is reliability? The keyword here for reliability is consistent. Here, that's the word, consistent. Now, how will you know if the instrument is reliable? The instrument is reliable when it will yield the same results once taken again. For example, I'll take a test on attitude towards mathematics today. After a year, I took the same test, the same instrument. Will my result be consistent? If it is, then your instrument is consistent. Now, there are three attributes of reliability. First is homogeneity. The second is, where's my pen? Homogeneity. The second is stability. And the last is equivalence. Let's deal on this one by one. What is homogeneity? Homo, one again, one. Or internal consistency. If you say homogeneity, it tells us if all the items on the scale measure one construct. Here, example, you have question items 1, 2, and 3. In validity, here's how you do it. Is this an attitude? Okay. Is this an attitude? Okay. How about that item number 3? Is this an attitude? Not okay, so delete it. You are just asking towards attitude. Is it a question towards attitude in math? In reliability, we check, is item 1 related to the second question? Is item number 2 related to the third item? If it is, then they measure the same construct. That's how you do it in internal consistency or homogeneity. Now, how are we going to do it? First is in split half correlation. How will you do split half correlation? Example, this is my instrument. My instrument has items 1 to 10. Actually, it's, for example, 1 to 20. I'll split it into half. So 1 to 10 will be answered by group A. 11 to 20 will be answered by group B. Or all even numbers will be answered by group A. All odd numbers will be answered by group B. And I'll check, is group A's answer similar to group B's answer? That is in split half correlation. The next is the average inter-item correlation. Remember I told you a while ago, in item number 1, what is the reliability index? Ma'am, how do we solve reliability index? We can solve it using the Excel or the SPSS. I'll teach you later. How about for question number 2? What's the reliability index? Question number 3, and we check, are these two correlated? How about the other one? Or another is the average item and total correlation. Example, this is my instrument. Let's go. This is the instrument of Ma'am Lil. And I copied her instrument. Okay, now. Then my students took the test with the same instrument. Is my data or is my result similar with Ma'am Lil's result? That is an average item total correlation. Now, the last, so again, those are two big words, reliability and validity. Let's go to the second one. The second is stability. That's a test retest correlation. How will you do it? I'll take the attitude towards math test today. In 1 year, I'll take it again. Will it have the same results? That is the test retest. If they will have both, then it means that the instrument is stable. How about for equivalence? This is my instrument for attitude towards math. I will make a version 2 parallel to this one. Then it could be the same user. Somebody will take both tests. Will the two versions yield the same result? If both are consistent, then you will have its equivalence. So again, our two big words for today, validity and reliability. Now, let me first stop my